Hello friends, in this video I am going to teach you about comparison between the frequency modulation and phase modulation. In this comparison I will go to teach some of the similarities and some of the differences between the frequency and phase modulation. First let's see, the first point is the mathematical representation of frequency modulation, that is modulated signal S of t is equal to Vc sin omega ct Vc sin omega ct plus mf sin omega mt. And coming to the mathematical representation of phase modulation, that is S of t is equal to Vc sin omega ct plus mp sin omega mt. Okay, these are the mathematical representation for frequency modulation and phase modulation. Now coming to the frequency deviation. Frequency deviation is always proportional to the modulating voltage. Okay, here frequency deviation means delta f. It is always directly proportional to the modulating voltage, that is amplitude of the message signal. Now coming to the phase modulation, phase deviation is proportional to the modulating voltage. Here also the phase deviation and frequency deviation both are proportional to the modulating voltage, that is the amplitude of the message signal. Now coming to the third point, associated with the change in Fc, there is some phase change. That means in frequency modulation the phase of the carrier changes, with that some phase also will be changed. Okay, that is this point. And coming to the phase modulation, that is associated with the change in phase, there is some change in frequency. Here also with phase there is some frequency also changes. Now coming to the fourth point, mf is proportional to the modulating voltage as well as modulating frequency of Fm. That means here modulating voltage is, that means modulating frequency is directly proportional to the mf is nothing but a modulated frequency. Here modulated frequency is directly proportional to the modulating voltage. Here also the same thing, modulated phase is proportional to the modulating voltage, which means here the phase of the carrier signal is directly proportional to the amplitude of the message signal. That is the meaning of this point. Now coming to the fifth point, it is possible to receive FM on a PM receiver, which means I already told you the relation between the FM and PM. By using that relation we can receive the FM wave by using PM receiver also. Okay, simply by placing one differentiator at the FM receiver we can receive the PM also. Okay, as similar to that FM, here PM also, it is possible to receive PM on a FM receiver. We can receive the PM signal on a FM receiver also by using that relation. Now coming to sixth point, noise immunity is better than AM and PM. Here the noise is very low when compared to the amplitude modulation and phase modulation. But here in phase modulation, noise immunity is better than AM but worse than FM, which means it is having less noise than AM but more noise than FM. Okay, now coming to the seventh point, the amplitude of the FM wave is constant. We know in frequency modulation only frequency of the carrier is changing, and remaining terms, that is phase and amplitude, are constant. And here also the amplitude of the PM wave is constant. Here also only phase is varying, amplitude is constant term. Now coming to signal to noise ratio, signal to noise ratio is better than that of PM. We already discussed that the noise in the PM is more than the noise in the FM, which means the FM has better signal to noise ratio, and PM, a signal to noise ratio is inferior to that in FM. That means it is somewhat more than the FM, less than the FM. Now coming to the ninth point, FM is widely used. We know in almost every radio station it uses the frequency modulated waves, that is it is widely used. And PM is used in some mobile systems, only some mobile systems are used the PM modulation. Now coming to the last point, that is in FM the frequency deviation is proportional to the modulating voltage only. I already discussed in the second point also, in FM the frequency modulation, that is delta f, is always proportional to the modulating signal voltage, that is the amplitude of the message signal, whereas in the PM The frequency deviation is proportional to the both modulating voltage and modulating frequency. In PM, the phase model or phase deviation, not a frequency deviation. Okay, here also we can take frequency deviation also. Here, here also we have somewhat frequency deviation. That frequency deviation is depends on both modulating voltage and modulating frequency. These are the comparisons between the frequency modulation and phase modulation. I hope you understand this topic. Thank you for watching this video.